Hi everyone, for today's math lesson we are going to be doing a paper review of Unit 5. So you will need in your workbook, you'll need these pages. Are you ready? I'm going to write them up here. You're going to need page 233, 235, and 237. Then you're going to put them in that order and you're going to staple them together in the top left corner. So go get pages 233, 235, 237, rip them out, and staple them together in the top left corner. Once you have done that, you're going to pause the video, and then once you have done that, you can push play again. You will also need out your orange crayon. You can tell that you need to put your name and number where it says name, and then I want you to take your orange crayon and underline where it says date and actually write the date. Okay? All right, let's move on to number 1. We're not going to be doing all of these problems together, but we are going to do some of them together, and then it is your responsibility, whether you get time in class or if you take it home, to finish the rest of this review packet, okay? Or at least the ones that we mark. We'll see how that goes with time in just a little bit. But let's begin with number 1. It says, select the expression that involves a shift of the digits to the right 2 places. Mark all that apply. Okay, remember when we shift digits to the right, it means that we're moving the decimal to the left. We talked about this early on with this unit, but remember when we do that, it's just by a power of 10. So if we're moving 2 places, then we're dividing by a second power, or 10 to the second power, which is also 10 times 10, which is 100. So underneath this right 2 places, we're going to write it's a 10 to the second, or it's 100, because that's what 10 times 10 is, right? So if I look at A, I would not be shifting the numbers 2 places, it would be shifting them 3 places because of those 3 zeros, so it is not A. B, I'm dividing by a power of 10, and it's 10 to the second, so the numbers would shift 2 places. So B is a correct answer. We will color in the circle and circle the whole answer. C, I would be shifting the digits 3 places, so it's not that. On D, we're shifting the digits 1 place, so it's not that. On E, we're only shifting the digits 1 place. And on F, we're shifting the digits 2 places because of those 2 zeros. And because we said that 10 to the second was 100. So F gets colored in and circled, and we're moving on to number 2. Classify each quotient as being equal to 52, equal to 5.2, or equal to 0.52. Write the letter of the quotient in the correct box. I'm going to have you put a star by this problem because I know that there is a problem very similar to this on the actual test. So you'll want to know how to do this for sure. So it just says, what is this answer going to be? Is it going to be 52, 5.2, or 0.52? So if we look at A, it's dividing, so it's taking 52 and shifting the digits 2 places. Okay? Shifting the digits 2 places. So if I'm dividing by a 10 to the second power, it is going to shift these 2 places. Here's what I like to think of it as. I like to think of it when you're dividing, you move the decimal to the left. So we're going to draw this arrow and then have decimal. So if I move the decimal 2 places to the left on A, the decimal's always at the end if there's not one in the number. So if I move it 2 places to the left, what does it become? 0.52. So A is 0.52. So I write the letter A in this box. Okay, letter B. I take and put the decimal at the end of 52, and how many times am I moving it this time? 1 place to the left. So go ahead and move it 1 place to the left, and what does it become? 5.2. So I take the letter B and I put it in the second box. See how this works? Okay, C. Put the decimal at the end of 520, and I move it how many places to the left? 1 place because of that little exponent. So if I move it one place to the left, it becomes 52.0, which is the same as 52. So I put the letter C in the first box. Letter D. I take 520, I put the decimal at the end, and I move the decimal 2 places to the left because of that 10 to the second. So when I move it 2 places to the left, it becomes 5.20, which is that like 5.20 is the same as 5.2. So it's D here. So you can see that there's multiple letters that come in some of the boxes. Okay, letter E. I move it 3 places to the left. The decimal is at the end of 520, and I move it 3 places to the left, meaning it becomes 0.52. And so that belongs in the third box. The letter E belongs in the third box. And letter F. I'm going to put the decimal at the end of 5,200, and I move it 3 places to the left, which becomes 5.200. And if I have zeros at the end, it's the same as just saying 5.2. So the first box has the letter C, the second box has B, D, F, and the third box has A, E. I promise you are going to want to know how to do this. So will you please make in orange these boxes as well and study how to do those problems. Number 3, explain why this answer has the same answer as this answer. Well, because when you times this divisor by 10 to the second power, you also have to times this dividend by 10 to the second power. So they become 4 as the divisor, and moving this twice becomes 360. So I would just say, because multiplying the divisor by 10 to the second power equals 4, and multiplying the dividend by 10 to the second power equals 360. Pretty simple. Number 4, why does dividing 5 by a decimal less than 1 give a quotient greater than 5? Why does dividing 5 by a decimal less than 1 give a quotient greater than 5? Because it's asking how many pieces are in 5. Well, actually I would say it's asking how many pieces we can get out of 5. And let's add the word 5 wholes. Number 5. A farmer ships 4 times as many oranges as tangerines. The farmer ships 8,260 oranges. How many tangerines does he ship? Write an equation, then solve. So we have to have an equation, then we're going to solve it. So the farmer ships 4 times as many oranges as tangerines. And here's the oranges. So it means this is 4 times the number we're looking for. Okay, so when you say this is 4 times, we're going to write this is 4 times the number of oranges. So this amount is. So it means the 8260 equaled 4 times x, whatever that is. So that seems really complicated, and so we like to use, when we use the word this is, remember that it's a turnaround phrase, and so we're going to use the division. So we take 8,260 divided by 4 equals x. And then let's solve for x. Oh, this is a division problem. I'll go ahead and do the division on the right. So set it up with 8,260 as your dividend and 4 as your divisor. 4 goes into 8 twice. Can you have a leftover of 0? Yeah. You just need to bring down the next number and ask the same question. How many times will 4 go into 2? 0 times. Because it won't go into 2, you have to put a 0 in the quotient. So you put a 0 in the quotient, and then you bring down the next number. How many times will 4 go into 26? 6 times, which is 24. So you write a 6 on the quotient line, you subtract 24, which you get 2, and then you bring down the last 0. And how many times does 4 go into 20? Exactly 5 times, so 5 goes on the answer line. You prove it by subtracting 20 and getting 0. So then solve. Because this is a story problem, we're going to circle our answer up here, and then we're going to put it in a sentence. How many tangerines does he ship? He ships 2,065 tangerines. That is going to be really important that you put story problems in complete sentences on this unit's test. Okay? This unit, you really want to be able to put the number in a complete sentence. All right, let's turn the page. When we turn the page, we're looking at the back side. So we're looking at page 234. All right, some more story problems. Let's do this. Jamal buys postcards at Washington, D.C. Of Washington, D.C. for $10.20, not including tax. Each postcard costs 85 cents. So this is the total he spent. Each one that he bought cost this. So we've got a total. We have the word. So this is a total. Then we have the word each. So how many postcards did he buy? If it was each postcard was $10.20 and he bought 85 of them, then you would be multiplying, but it's not. It's saying this is his total. I'm going to write total. You should always write what I'm writing. This is his total, and this is how much they cost. So you're doing division. I know, this is a division unit test. Weird, huh? Okay, so we take $10.20 divided by 85 cents. I'm just going to do that right here. $10.20. Sorry, that's a 0. The staple there. Made that a little complicated. And I'm dividing it by 85. Now, you can put the dollar signs in there if you want. Whenever you're dividing a dollar sign by a dollar sign, though, they actually just cross each other out. So you could have just done 10.20 divided by 0.85. Because we're looking for not a number. Sorry, we're looking not for an amount. We're looking for how many he bought. So that's why it's not going to be a dollar sign in your answer. Okay, well, we've got some interesting things going on here because it's a decimal and a decimal. So a decimal divided by a decimal. We got to get rid of the decimals. So I times this one by 10 to the second power so that I can get rid of it. So this new number becomes 85. And if I times this one by 10 to the second, I have to do the same thing to this one. Well, how convenient. It just goes all the way to the end. So it looks like this. I could put a decimal up in my quotient line in case, but you can't buy a piece of a postcard. So if you have a remainder here, there's a problem. Okay? Think about it logically. All right. 85. Well, it's close to 90, but let's just use 85 for a minute because 85 won't go into 1 or 10, but it will go into 102. Only once, though. Because if you double that, it's already into the 160s, 170s. So it's only once. And when you minus 85, make sure to stack it in the right place. So it's under the 2 and 0. So 85. Which means you're going to have to be doing quite a bit of borrowing because 2 minus 5, you can't do that. You can't borrow from a 0. So you borrow from the 1, make that a 10, and then borrow from the 10, change it to a 9, and make the other number be 12. Now we're in business. 12 minus 5 is 7, and 9 minus 8 is 1. Can you have a remainder of 17? Yeah, the number is 85. And then I just bring it down to 170. Well, it's going to be 2 times, and some of you will understand this, and some of you are struggling with it, so listen really carefully. I know it's going to be 2 because 80 doubled is 160, and 5 doubled is 10, so 160 and 10 make 170. That's a good mental math strategy for doubling, and just prove it. Okay, so how many postcards did Jamal buy? Watch, I put the answer here. I write it in a complete sentence because it's a story problem. Jamal bought 12 postcards. If you don't write that sentence, you're not going to get the full points, especially on the test. So take your time and make sure it gets done. All right. I know for a fact that a problem like number 7 is on the test. So I would make sure you know how to do this one. If I give an area and one measurement, it means I'm doing division to get the other measurement. Okay, so let's do that division. I'm actually going to maybe try to do it right here. So we take 95.9 as the dividend, and we divide that by 14. Okay, I don't have a decimal in the divisor, but I have one in the dividend, so what's the rule if it's just here in the dividend? It's to move it straight up. So move it straight up into the quotient. Do you know your 14s times tables? I don't really, but 15s are easier for me, so I'm going to use 15. Remember, this is that double digit, estimating helpful tool. So I use 15, and I'm trying to get it to get to 95 because 14 won't go into 9. So if I go for 15 times 4, it's 60. So 15 times 5 would be 75. 15 times 8 would be 90. 15 times 8 would be 90. That's getting really close. I think I might try 14 times 8. Wait, 15 times 5 was 70. Oh, it was 6 we were supposed to try. Oh, goodness. Do not erase that. Never want to erase math like that. That cracks me up. I was like, wait, it can't be 8. So we're trying 6 is what we were supposed to try, I think, right? Because 4 was 60. 5 was 75. Yeah, it's 6 we're supposed to try, not 8. Goodness, why didn't you stop me? Just kidding. Okay, 6 times 4 is 24. That feels way more right. Okay. So funny. So put a 6 in your quotient line. But where does the 6 go? It goes above the 5 because we did 95 and we got 84. So it's 6. And then I subtract and I get 11. It can be 11 because that's less than 14. And I bring down the 9. See why I said don't erase it? That if we would have erased this 14 times 8, we would have been having to do the work again. So it's never a good idea to erase when you're trying out multiplication because you could end up using it. Do you see how we're going to end up using it? Yeah. Okay. So, 14 will go into 119 8 times. So you put the 8 on the quotient line, and then you subtract 112. And then you get 7, right? Well, you can't have 6.8 remainder 7. You can't do that when you're dealing with decimals. So I know something that's pretty cool about the number 7. Do you? Look at the divisor. 14. What is the relationship between 7 and 14? 7 is half of 14. So I know that this is going to be a 5 as the decimal. I just know it. Because whenever you deal with halves, that's represented with 5s in decimals. So, but I'm just going to prove it. I'm going to do that drop down 0. And 14 times 5 is going to be 70, I bet. Look at that. Prove it. On the test, if you run into a problem where you see that it's exactly half, I would still do the drop down 0 to prove it. But then with a star for extra credit, I would maybe say 7 is half of 14, or The remainder was half of the divisor, so I know the decimal has a 5. You could say that for extra credit. That's a great idea. Okay, so I have the answer, 6.85. It is a story problem. So what is its width? The width is, let's go ahead and put all of our sentences from this point forward in a cloud. Actually, I'm going to go do the one about Jamal too. I love number 8. I love, love, love this problem because it happens all the time, stuff like this. Ready? Mr. Adams divides 223 markers equally among the 26 students in his class. He puts the extra markers in a box. What is the least number of markers he puts in the box? So they're not actually looking for the answer. They're looking for the remainder. Because remember, he's dividing out his markers evenly, and then he's going to put whatever's left over in a box. So they're asking, what's the number he puts in the box? So you take 223, and you divide it by 26. Will you highlight the word equally? Because that is going to show us that it is division. But I'm looking for the ones that he puts in a box, which is why we're looking for the remainder. So set it up. Come up really tall up here, 223 divided by 26. I love 26 because it's really close to 25 and I can count by quarters really well. Okay, 26 won't go into 2 or 22, so really you're just looking for this one time. How many times will 26 go into 223? Well, use quarters for a minute and count by 25s. 25, if I have 8 quarters, it's 200 cents, right, or $2. So 8 times 26 would be 200 plus like 6 times 8 more, so 48 more. So I think 8 would be too much, is what I'm saying here. I don't know. Maybe it wouldn't be. Should we try 8? Or do you think it's 7? Think about that for a minute. I don't know. Let's try 7. Let's see what happens when I do 26 times 7. 14, 15, 16, 17, 18. Could I get 26 more out of here? 20 more would be 202. Yes, I could have. So I'm going to prove it by doing 8. Just so you know, Miss Fisher knew that it wasn't going to be 7. But I wanted to show you that it's okay if you make an estimate that's too low. I didn't erase it. I wasn't upset. I just went, well, I estimated a little off, and I'm going to try the next one up. But if I would have put like, well, let's just try 2 or 3, I'm pretty far off. So I'm not unhappy with my estimate. I was only 1 away from it being correct. So I think this is a good skill to practice. That's why I had us do it. You need to have both multiplication problems on there. Okay, so 26 times 8 was 208, and so I put the 8 up here and I subtract 208. And if I get a number that's 26 or higher, I did something wrong. Remember, it cannot be higher than 20. Technically, it can't be higher than 25, but it can't be equal to the divisor. Otherwise, this should have been 9 up here. Sorry, subtract, see what you get. Whew, good. I got 15, and that's less than 26. So I don't go, oh, the answer is 8, remainder 15. Remember, he's dividing the markers equally among his students. So each student got 8 markers. This lovely little 15 is what he had to put in the box. So the answer is 15, and then I put it as an answer. He will put 15 markers in the box. We'll say he can put. Okay, Okay, that's the complete sentence. I'm going to put it in a cloud and move on. Number 9. A park creates new habitats for 182 monkeys. How cute. Each habitat will house 8 or fewer monkeys. Okay, so we have a total of this many monkeys. We're saying each, and they're going to fit 8 in there. What is the least number of habitats the zoo will need? What did you do with the remainder? Explain why. Ooh, there's going to be a remainder. So that means we're going to have some monkeys not fitting into habitats. Should you leave the monkeys out? No. So be thinking about that. Okay, let's set it up. 182 divided by 8. Should be pretty easy. 8 doesn't go into 1. 8 goes into 18 twice. So put 2 on the quotient line. Subtract 16. Get 2. Bring down the 2. And 8 goes into 22 twice. So that's 16. Subtract. And you get 6. So it's 22 remainder 6. That's not what that means. It means the park creates new habitats. So it means they're going to have to build 22 habitats. But if they only build 22, they will be leaving out 6. So we're going to write, don't leave them out. So if they want to house all the monkeys, how many habitats will they have to build? If they build 22, they're going to leave out 6. So do they need to build 40? No. You just take this number of habitats and you round it up by 1. Because if they built another one, it would get to fit 8 monkeys. I only have 6 monkeys, so there'd be extra space for the monkeys, but I still would not leave them out. So you have to take your answer and add 1 to it. What you're doing is you take your quotient and you add 1 or you round up by 1. Remember that lesson? So, what is the least number of habitats the zoo will need? 23 habitats. So they will need, this is a story problem. 23 habitats. And then what did we do with our remainder? We rounded up our remainder by 1. That's what we did, so put a period on that. But why did we do that? Because no monkeys should be left out. I don't need to put a cloud around that because it's already in a box. We're not going to do number 10. I don't want you to have to model that. I feel fine. Move on. We'll catch you in the next video where we'll work on the following pages together.